Hi, so in today's video I'm going to continue to look at similar shapes. So this is the second part of this, and there'll be one more part after this as well. And in this section I'm actually going to look at the area of similar shapes, so rather than just focus on their length, looking at the area as well. So what I've drawn for you here, and this will need a little bit of explanation, is I've got initially two rectangles. Now I'm going to tell you that they are mathematically similar. So not all rectangles have to be mathematically similar, but I'm telling you these two that are. And if you remember from the previous video I did on this, that means that they have two properties. One property is that all the corresponding angles are the same. Now in this case every rectangle has the same angles anyway, because all four of them are 90 degrees, which you should know from your properties of quadrilaterals. But the other fact, which is really important, is that all the sides are in the same ratio. So in other words, that means that whatever the scale factor is to go from a length on this side, on this shape, to a length on this shape, it will be the same for the corresponding sides. So I'm telling you they're mathematically similar, and I've given you the two lengths on the smaller shape, but I'm not telling you what this one is here. Now you should be able to work that out based on what we did in the previous video on this, but I'll just give you a quick refresh. So what we've got here is our corresponding sides, and you can see which ones are corresponding because of the diagram. So this side is the longer one, this one's the shorter one, and the same here and here. So therefore the corresponding sides would be the 5 and the 15. And you remember, if you want to work out the scale factor, you do the bigger one divided by the smaller one. So in this case we're going to do 15 divided by 5, which hopefully you can do in your head, which is 3. So that means our scale factor is 3. But because I'm adding another dimension to this, which is now moving on to area, I'm actually not just going to call it the scale factor, I'm going to call it the length scale factor. And I'm going to tell you, I'm going to abbreviate that to LSF, so that it's a bit easier later. So the length scale factor is 3. So that means if I want to work out, if I've got one of the smaller sides and I want to work out a length on the bigger side, I have to multiply by 3, and to go from a big to a small, I divide by 3. Again, you should remember that from the previous video that I did. So if this is 5 and this is 15, that's using our scale factor of 3. I know that this side, which is the shorter one here, is 4, so all I have to do is 4 times by our scale factor of 3, which tells me that that missing side over there is 12 centimetres, so I can fit it in now. So that side is 12 centimetres. So that's our recap. But what I want to do now is I want us to think about the area of these two shapes. Now I've chosen a rectangle because it's nice and simple, but you can do this with any similar shapes. So if you remember rightly, to find an area of a rectangle, we multiply the two sides together. So the area of this shape is just 5 times 4, which is 20 centimetres squared. And then for this rectangle here, I do exactly the same. This time I do, the area is equal to 15 times by 12, which actually gives us 180 centimetres squared instead. Okay. Now, what I want you to think about now is have a look at these two areas. Now, when we were comparing the lengths, we went from 5 to 15, we just times by 3. 4 times by 3 gives us the 12. Okay. The scale factor there was just 3. But what's happening this time? Well, if we think about our areas, this area is 20, this is 180, and in actual fact, what we've multiplied by here is 9, not 3. And there's a simple reason for that. The 5 has been multiplied by 3 to give us 15. The 4 has also been multiplied by 3 to give us 12. So if you think about it, you've done 5 times 3 times 4 times 3 to give us the 180. So 3 has been multiplied twice. So therefore the area scale factor is actually 3 squared, which is 9, okay? And we can generalise that to say that if the length scale factor, so this is where my abbreviation comes in, is K, then the area scale factor, ASF, is K squared. And that will always be the case. So if we've got one, we can get the other, and vice versa. So let's have a look at this example here then and put that into practice. So again, I'll give you the narrative around it, because obviously this is, I don't have a lot of room on here, so I've just given you the diagrams. In a proper question, it would state that these two shapes are mathematically similar, and the question would ask you to find the area of this shape here. So we're told they're mathematically similar, and we've got to look at the information we're given. So you can see from the diagrams which way round they are. You can see that you have here these two sides which are your corresponding sides, and you can see that nicely from the two diagrams that we've got. So we can use these two to be able to compare and get our scale factor, and importantly we need to know it's our length scale factor. So what I would really encourage you to do is write down which scale factor you're finding. So in the first instance we're going to find the length scale factor, and we do that, remember, by doing the bigger one divided by the smaller one, which is 20 divided by 8. Now you can do that either using a calculator, okay, or you can just cancel it down if this happens to be on a non-calculator paper. And this one is actually, if you cancel that down, 4 goes into both of those. 4's into 20 is 5, 4's into 8 is 2, so it's 5 over 2, which is 2.5. So your length scale factor is 2.5. Now, it's the area that we're needing, so we need to basically now calculate the area scale factor. So, the area scale factor, whoops, okay, is just 2.5 squared, which is 6.25. So that is your area scale factor. And then all you need to do is you need to work out, well, are you going from big to small or small to big? Okay. Now in this instance, we are actually going from big to small. And remember, if you're working from big to small, you divide. Okay, just the same as when you're finding missing lengths, it's no different for areas. So our missing area, let's call it X. I always think it's easier if it's got a name. So our missing area X is just equal to the area of the bigger shape, which is 75, divided by the scale factor, and it's the area scale factor, importantly, which is 6.25. And if you do 75 divided by 6.25, and you can just do it on your calculator, you get 12. Now remember your units, this is an area, so it's 12 centimetres squared. So just to recap, okay, you need to find, first of all, find your area scale factor, okay, and then what you need to do is work out whether you're doing a division or a multiplication, and once you've got that, you just do that sum, and then you have your answer, okay.